sometimes data might be presented to us not as a list, but rather as a table. And there are various reasons why this might be the case. It might be as simple as the fact that there is so much data, putting it in a table would make it easier to read, easier to summarize, than having it in a list would be. Now, we've already seen how we find averages, mode, median, mean, and that range measure of spread from lists of data. We also need to be able to do the same for data from tables. Well, the first thing it's important to do is be aware of the sort of information that we might have in tables and what the different numbers mean. Well, let's have a look at a particular example. Consider the following data about people's shoe sizes. So we have a table here with two columns in. Shoe size and frequency. Let's have a look at the shoe sizes first of all. We have shoe sizes 3, 4, 5, 6, 7, 8, 9, 10 and 11. They are the individual shoe sizes. So presumably somebody went round, did a survey, maybe some sort of questionnaire, or just asked them a question, what is your shoe size? And these were the results that were obtained. Everybody who was asked was either shoe size 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10 or 11. The results, the number of people who were that shoe size, were then summarised in this column, frequency. Now, frequency is just a fancy way of talking about the number of times something happened. In this case, that would be the number of people with that particular shoe size. So this 4 here means that there were 4 people who had a shoe size of 3. 2 people who had a shoe size of 4, 6 people who had a shoe size of 5, 7 people who had a shoe size of 6, 1 person who had a shoe size 7, 9 people with shoe size 8, 10 with shoe size 9, 5 with shoe size 10, and 6 with shoe size 11. So the frequency is the single most important piece of information. Question number 1. How many people were asked their shoe size? The answer is not 9. Where would the 9 come from? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. The answer is not 9. There were not 9 people asked. There were 9 different shoe sizes given, 9 different results. But bear in mind what that frequency column means. 4 people have shoe size 3, 2 people have shoe size 4, 6 people have shoe size 5, and so on. That means that there were 4 plus 2 plus 6 plus 7 plus 1 plus 9 plus 10 plus 5 plus 6 people asked in total for their shoe size. How many people is that? Well, if we add those up, we would get that there were 50 people asked in total. 50 people, not 9. Well, the first average we could find the mode. We could work out which was the most common shoe size. You might also see this question phrased as being asked to give the modal shoe size. It's just a different way of asking the question. The modal shoe size and the mode would be the same things. In fact, if anything, the second one, while it's got this complicated word modal in it, the fact that it reminds you it's a shoe size means you need to give one of these shoe sizes, 3, 4, 5, 6, 7, 8, 9, 10 or 11 as the mode. How would we find the mode? Well, the mode is the one that happens the most. So the mode, if it's the most common, would have the largest frequency. So we look down the frequency column, we find the largest frequency, and it would be this 10 here. So the 10 is the largest frequency. 10 is not our answer. We need to make sure that we give the shoe size that happens the most, and the shoe size that happens the most is shoe size 9 because it has the largest frequency. So 9 would be our answer. The modal shoe size, or the mode, 9 because it has the largest frequency. We can also work out the mean from this table. But in order to work out the mean, we need to think first about what the numbers mean again. We need to think what that frequency is doing. Imagine that we took this information out of a table form and wrote it in list form. So it's now in table format. Imagine we turned it into a list, so it was not in table format. These frequencies mean that we would have 4 people with shoe size 3. So we'd have 3, 3, 3, 3. And then we'd have 2 shoe size 4s, so 4 and 4. And then we'd have 1, 2, 3, 4, 5, 6 5s. And then we'd have 1, 2, 3, 4, 5, 6, 7 6s, and so on. To find the mean, what we'd then do is we would then add up all of those different shoe sizes. And we would then divide them by how many individual pieces of data there are. So we'd be doing 3 plus 3 plus 3 plus 3 plus 4 plus 4 plus 5 plus 5 plus 5 plus 5 plus 5 plus 5 plus 6 plus 6 plus 6 plus 6 plus 6 plus 6 plus 6, and so on. And that would take us a long time. So now think whether there is a quicker way of doing that. Could we, for example, add these 4 3s together in a much quicker way? Could we add these 4s together in a much quicker way? The 5s, the 6s, and so on? Well, yes, we could. Because quicker than doing 3 plus 3 plus 3 plus 3 would be just doing 4 lots of 3. 2 lots of 4, 6 lots of 5, 7 lots of 6, and so on. I.e., taking the shoe size and the frequency and timesing them all together. So what we're going to do is we're going to extend our table like this. So we've added an extra column on the end of the table. Now in this column we are going to put the results of that very multiplication. We are going to take the shoe size, and we're going to take the frequency, and we are going to times them together. This is our short, quick way of adding up all of the data. So we're going to do 3 times 4 gives us 12, 4 2s are 8, 5 6s give us 30, 6 7s 42, 7 times 1 is 7, 8 times 9, 72, 9 times 10 is 90, 10 times 5, and 11 times 6 for 50 and 66. So we're going to fill in all of those values. Once we've done that, we need to total up the whole list. So I'm going to take those numbers 12, 8, 30, 42, 7, 72, 90, 50 and 66, and I'm going to add them all up. And in doing that, I'm going to come out with a total of 377. I also need to add up the frequencies. Now we did this before. This comes to 50. That means we have 50 items in that list, and the total of the list is 377. We can now work out the mean of the numbers. The mean, then, would be that total 377 divided by the 50 pieces of information, giving us a mean of 7.54. Notice that 7.54 is, while not one of the actual shoe sizes, falls nicely between 2 of them. It is contained within the set of data. The mean will be somewhere between the smallest and largest values of data. So that mean is a sensible mean, giving us a mean shoe size of 7.54, 7.5 pretty much. We might also want to work out the median from a set of data in a table. Well, for the median, we want to think about what we need to do. To find the median, we take our data, we put it in order of size. Well, there's the first thing. This data is already in order of size. It starts at shoe size 3 and runs up to shoe size 11. It's already in order of size. How the median works? Well, we look for that center value, that middle value of the data. How many pieces of data are there in this set? Well, there are 50, because we've seen that already. There are 50. So 3, 3, 3, 3, 4, 4, 5, 5, 5, 5, 5, 5, and so on. The median would be the middle piece of data, and the median would surely then be the 25th piece of data. If there are 50 pieces of data, the 25th one would be the middle. So where is the 25th piece of data? Well, here are the first 4, and then the next 2, so that's 6, and then 6, so that's 12, 19, 20, and then 29. So the 25th piece of data would fall somewhere in there, which means that the median must be a shoe size of 8. We could also find the range of the data in the table. Not an average, remember, but a measure of spread. But we could find the range. Well, the largest shoe size is 11, the smallest shoe size is 3, and finding the difference between those would be a range of 8. Again, quite a small range, suggesting that perhaps the numbers are fairly consistent, which makes sense because there isn't a massive variation in terms of people's shoe sizes. Now, sometimes data might be presented to us slightly differently in a table. Rather than single discrete pieces of information like we had previously with the shoe size 3, then 4, then 5, then 6, and a frequency given for each, we might be presented with data that's been arranged conveniently in a table into groups. Like this. Consider the following data about the number of hours of TV that people watch in a week. So we have hours of TV 0 to 5, 5 to 10, 10 to 15, and 15 to 20, and then a frequency attached to each of these. Now we can still look at the frequency and work out something about the data here. That 6 in the frequency, the 8, the 12, and the 4 are still the most important things in this list. This 6 here, for example, means that there are 6 people who watch between 0 and 5 hours of TV in a week. But how much TV do they watch in a week? As in, do they all watch 0 hours of TV? Do they all watch 5 hours of TV? Do some of them watch 0, some of them watch 1, some of them 2, some 3, some 4, and some 5? Do some of them watch 4.5 hours of TV? We don't have any information about those 6 people other than they watch between 0 and 5 hours of TV. Similarly for the 8 people watching between 5 and 10, and so on. And yet a question could say, and the wording will be very careful here, estimate the mean number of hours of TV people watch in a week. Well, we're asked to find the mean. We know how to find the mean from a table of data, but the key word in that question is estimate. We will come back to that word at the end. This is the only time for estimating that we actually need to work something out. But I will explain at the end why it is an estimate and not the actual mean. The data in a table, to find the mean, we need to know 2 things. We need to know the total of all of the data, all the numbers in that data, and we need to know how many pieces of data there were in total. Well, we can do that one easily enough. Number of pieces of data, 6 and 8 is 14. Plus the 12 plus the 4 gives us 30 pieces of data, 30 individual pieces of data. So when we're doing our mean, we're going to be dividing by 30. But we also need the total of the individual numbers in there. And the problem is, we don't know what the individual numbers are. So what we're going to do is we're going to make an assumption. We're going to choose a number from each group that roughly describes the numbers in that group. The group 0 to 5, for example, we're going to pick something from within that group to describe them. And we're going to say, let's assume that all 6 of the people in that group watch this many hours of TV. Before we do that, we're going to extend our table. And I'm going to add 2 extra columns this time. As the first column, we're going to fill in with our value that we are assuming. We're going to choose a value from between 0 and 5 that is us assuming that all 6 of those people take that value. And what we're going to do, every time, for any of these questions, we're going to choose the midpoint. We're going to choose the dead middle of the group. Now that makes sense as a choice. Think about it. Probably some of the people, some of the 6, watch less than that middle value, and probably some of the 6 watch more than that middle value. But if we're picking the middle one, they're kind of balancing it out. The smaller ones and the larger ones are sort of balancing out to give us that middle value. So assuming it's the middle value, it will give us roughly the mean by the end. So we're going to pick the midpoint. So we're going to pick halfway between 0 and 5, so 2.5. We're going to pick halfway between 5 and 10, so 7.5. Halfway between 10 and 15, so 12.5, and halfway between 15 and 20, so 17.5. And they are our assumed values. So we are now assuming that 6 people watch 2.5 hours of TV a week, 8 people watch 7.5 hours, 12 people watch 12.5 hours, and 4 people watch 17.5 hours. And now we can ignore that first column, and this question is just like the previous question for finding the mean. We've got single pieces of information and a frequency attached to those. So what we're going to do in our final column is we're going to do the frequency and we're going to times it by the midpoint. I'm going to do 6 times 2.5, 8 times 7.5, 12 times 12.5 and 4 times 17.5. That's going to give us 15, 60, 150 and 70. We're then going to take these values and we're going to total them up, because this is us finding the total of the list. So we're going to total those numbers up, and that's going to come to 295. So the mean then, 295 divided by 30 to give us 9.8, falling nicely as one of the values within this set of data. Why is this mean an estimate? Well, because we don't know for sure that those 6 people watch 2.5 hours of TV. We don't know for sure that the 8 people watch 7.5 hours. That's why it's an estimate. We've still worked everything out properly. We've not done any random rounding in there, but because we've made that assumption, so we've chosen a value to represent each group, that's why it's an estimate. Because we can't guarantee that the mean, if we were to find the original pieces of data, would be exactly 9.8. A final note on grouped data in tables. There are 2 ways that the groups might be presented to us. This is one of them. If we were talking about hours of TV again, we could have between 0 and 5 hours of TV. Or it could be presented to us like this. In this inequality format, remembering that anything like that means that X, the number of hours of TV, say, would be sandwiched between 0 and 5. It doesn't become an algebra question, it's just a way of writing the group. They are both exactly the same thing. Both of these, besides being a group of data, it could also be called a class. It's just a fancy word for group. So if you're asked to give the modal class, it just means which group is the most common group, which group has the highest frequency.